Well, I want to take a look at this little amp, do a quick refurb on it, so I can give it out as a loaner to my parents probably. I may fix their amp before I even get this back to them, I don't know. SA155. Optimus SA155 integrated stereo amplifier. And I think I'm going to do a little modification to it. The reason I didn't install it at their house was I didn't have any way to hook the speakers up to a frickin' RCA connector. I really detest that. It annoys the heck out of me to have that as a... They're doing a lot of low power amps like this. It's not a good way to go though for speaker jacks. Easy for them. So I started making a little template here. I shifted around too much. I should have mounted these down with some glue stick, real tight together, the way they'd be mounted on the panel. And then made my template carefully. I fussed around. It's kind of useless. Anyway, I'm going to probably mount these right here. And I may even turn these old jacks into a second pair of tape outs. Maybe I'll even go as far as looking at the schematic of this thing. I haven't even looked at it yet. I don't know if it's a output capacitor or if it's a split power supply type design. I don't see a pair of output capacitors here. I don't see the filter capacitor either though. Well, there's only one filter capacitor. Maybe it is a single-ended and just the output caps are that small. If that's the case, I would definitely make them bigger. So I might hop it up a little bit. We'll see. So back to the Big God amp. You used to say Big God in the back. It doesn't anymore. Anyway, it was used in a church at one point. I don't really know for what, because it was a big church. It's not much of an amp. This is a 1.8 watts per channel. The curious thing is the chip that it's made from is actually a 6 watt per channel chip. Of course, that's 4 ohms and that's 10% distortion. So, you know, maybe 3.5 watts per channel, like a typical Class AB amp would do, in 8 ohms. You had a reasonable distortion. So, it's kind of curious they didn't go for a little more power. And they did the same stupid thing they always do in these amps, and I know why they did it early on. Using a center tap transformer, and then just using 2 diodes. And that's using half the transformer at a time to give you a full wave out of it with 2 diodes. It's like wasting half your transformer, which you wouldn't want to do in an audio amp. You know, a transformer is a lot more expensive than 2 more diodes to have a bridge rectifier. They could have used a smaller voltage transformer with only 1 winding, didn't need the center tap, and you know, a little more VA to the transformer, could have squeezed a little more in there, and they could have gotten real near, you know, 3.5 watts per channel with a decent transformer, and, you know, a cheaper transformer to save money not having a center tap. You would think that would be enough to pay for the other 2 diodes it would take to put a full bridge rectifier in. A full bridge rectifier. Like a man. So this wimpy little 2 diode thing, which are buried way down here. Little things on the board. You know, time this thing was made, that economy was, I mean, I guess it was designed way back. It was originally gold panel, Radio Shack brand, and then it became, at some point it was marketed under RCA, and then eventually Optimus. So this is like the latest of it, but they still carried through what they did originally. You see that in a lot of products where they never update things. You kind of wonder why. Like the selenium rectifiers and the chargers that you can still get, I believe, even now. At least up to recently anyway. So I've done a couple modifications on this guy. I moved the line cord, which was not easy. I got that to release finally, and drilled another hole off to the side, remounted the line cord. But I put this speaker block in instead of these stupid RCA jacks, which I hate for speakers. I wasn't going to put these in, but they're just slightly bigger, they're just slightly harder to fit in there. Stole this from a different project. Nibbled it in with a nibbler, starting with the hole, you know, left by the line cord. So that's done. That was kind of an effort. So there's 3 wires coming from the front here that carry the output power to the speaker jack. So I just removed them, 3 holes there. Just pulled this ribbon out, 3 holes, unsoldered from the other side, and moved the wires to the new jacks. So that's easy done. And then at this point where the 3 holes were that connect to these RCA jacks in back, I capacitor coupled them into lines just after the volume control. Well, actually the center conductor, the center post of the volume control. I hope. I got to check to see if I did that right. There's actually 8 contacts, 8 points on the volume control here, and I think it's for a loudness tap. And I'm guessing the loudness tap's in the back, and then this tap. These are the 2 taps I went for. We'll see though. I could be dead wrong. I'll find out real quick when I go to test this thing. So the idea is to make these speaker out jacks preamp out jacks instead, so you could plug a power amp into here. So this chip was geared for automotive stereos, car stereo. So its recommended voltage is 13.5 volts or 13.2, something like that. I cut off the ratings here, but it had kind of an odd thing. Quiescent for like 30 seconds, you can run up to 25 volts. Operating it was, I think it was 18. And then the other one was recommended was, they don't have recommended here, they have it somewhere else at 13.2 or something like that. There's a sample circuit. It's just real simple, basic. And it does have 1000 mic caps in the output. They're really tiny, but they are 1000 mics. And the filter cap's 2200. So they're all real minimal. I could make the thing work a little better by boosting those. If I really wanted to get more power out of this, I'd have to stiffen up the power. I suspect this must really droop, because the voltage in this thing, as I was getting around to, is like 20 volts. Probably 18 under load, but it's running near the max of this chip. It should be able to get, you know, the full power out. I don't have any reason this chip can't do its full power. Now the heatsink obviously can't do much more than the rated wattage, you know, 1.8 per channel either. To do anything, you got to improve that heatsink. And back to my modifications, I identified these spots on the volume control. I hope I got to test that out. I used a couple caps to tie them to those old points and to ground from the same 3. So there's 3 wires here, and I just continued them to 3 wires here. And hopefully that'll give me my variable output for my power amp driving output, preamp out. So it's clipping pretty good.
It's true, but you must stop crying.
Wow, the heatsink works really poorly. They just used a little flap of the chassis. So under one finger, I can feel a pretty hot spot. The other finger, lukewarmish. I mean, it's not transferring the heat very well at all across even the length of this piece of metal. It's not good metal for heatsink. So that's a big limitation. Something that has to be addressed if I ever did get a better transformer. And I clipped the scope into one of the outputs that I added on, these power amp driving outputs. It looks like I got it right. If I turn the volume up, level goes up. So it's tracking. So I got the right points off the control. So that's an old trick on these older electronics. Use the volume control as a point to tap in and tap out for to separate preamp from power amp. You can usually use the center tap of the volume control. Nowadays, that's not so reliable. A lot of amplifiers, you'll actually have a DC voltage on the control pots and electronic volume control inside the circuitry somewhere, if not part of the chip amp. So a lot of times you'll have a DC voltage instead of audio, but if you got audio like you did in the old days, older designs, that's usually a good place to tap in and out for the power amp. I could also get a slight power boost just by changing out the caps, putting a bigger supply cap in and bigger output caps in. It would be pretty minimal at this point. If I upgraded the power otherwise, I probably would do the caps as well.